So next we have to understand some garbage collection related code here. So if you can look at here, there's the one class we are having garbage test, and then we are having say public static void main a runtime rt runtime dot get runtime. So this runtime will help us to get the runtime environment. So rt is that having environment, and then we can say rt dot total memory and rt dot free memory. So what is the total memory and what is the free memory here? So we are getting the total memory, and here we are getting the free memory now. Now date d equal to null. So we are creating one object of date which is in util package, and then we are saying here for int I equal to 0, I less than 1000, I plus plus. So we are creating object of d and then we are making it null, right? If I'm making it null, it doesn't mean immediately memory is getting free. No, it is becoming garbage. So d is becoming garbage, and again we are going here loop and just running, and then we are saying d equal to new date. So you can, if you can see this here, let us say this is your d and this d in the memory, and you are saying new date, right? New date. So one date is coming, and then you are making it null, so it is becoming garbage. And then again you are saying new date, again you are making it null, again you are saying new date. So it is keep acquiring memory and making it garbage, right? But not freeing the memory, remember. After memory is, so now we are saying rt dot free memory. So earlier free memory and now free memory will be less. So if we can compare this two value, we are getting the less, right? Earlier it was 1605500, now it is 159477792, right? Now what we are doing here, rt.gc. So we are requesting to claim memory, or we can say system.gc. So this will help us to claim the memory, and then we are finding free memory. So we are getting the memory back, right? Even it is giving more, like it may be some previous garbage which has been collected here. Okay, so you can run it once again and you can check it here. What is the output you are getting for this code now? Next, so if you can see this code, it is, or what we are trying here, that we are trying to find out like how much memory has been acquired for allocating memory for certain number of object. So consider this is a get runtime, and here we are saying sometimes new integer 1000. So we are just making an array of 1000 integer object, and there's a two variable memory 1 and memory 2. So first we are finding the total memory, and then we are finding the memory 1 and saying free memory. What is the free memory? And then again we are saying garbage collection, so claiming the memory, and then we are finding the final free memory at this place. So what are the numbers are coming, you can check it out here. Now what we are doing here, we are allocating 1000 integers here, right? 1000 integers we are allocating, and then after we are finding what is the free memory. So it is giving me memory 2, right? So earlier free memory was this, now free memory is this. So if I find the difference between the previous and next, I'll get the memory used by allocation of this 1000 integers, right? And now we are making it null, right? And then we are saying r.gc, claiming the memory and then finding the free memory, and again printing the free memory. Okay, so this guy is giving me how much memory has been acquired for allocating this 1000 integer. Clear? Now next is what, JConsole. This is one tool in JDK 1.6. When you type JConsole here on this command prompt, I mean just write JConsole, you will get this screen. What is kind of this screen? It is a Java monitoring and management console. So once you're writing JConsole, it is giving you the Java monitoring and management console where you can select local or a remote process. So you want to see your local Java virtual machine details, you can just select local. If you're looking for some remote system, you can just pass the address and then username password and then say connect. Once you are connecting, you will be getting some kind of this interface. So look it now. Okay, so now look at this image. Once you are saying and selecting your local process, it is giving you the overview, some details, and then it is telling you perform this, you can claim your garbage. Now here is the heap memory and this is the non-heap memory. So it is saying that how much heap memory has been used and how much non-heap memory has been used. So you can check it out. If you go through this tab like threads tab, you will get how many threads are running, how many threads are daemon threads, how many threads are uh, live. Okay, how many class has been loaded, how many class has been unloaded, what is the virtual machine which you are using, the name of virtual machines, and ambience and all you will be getting here. So it will give you the complete picture of your Xavier. So okay, next some quizzes here. So a dash loader loads the Java API classes when a Java program is executed. What is that? It is a primordial class loader, right? Memory for an object can be allocated using the operator. What is that? It is a new. Here is the primordial class loader. Class loader. Here is the new. The dash makes a Java program network mobile and platform independent. Class file, right? The garbage collector runs the method of an object before delocating the memory associated with it. What is that? Finalize method. What is that? Finalize method. Garbage collector can be called manually using the which method? So there's a system.gc. You can write here system.gc method, right? The dash monitors the situation and uses the best suited garbage techniques. Adaptive collector. Adaptive adaptive collector, right? The problem that arises as a result of allocating and delocating memory is called, what is that? Is a garbage collection, right? Okay, so that's all.